Warning, flashing lights and choppy audio. Thanks for watching. Part 2 releases soon? I hope. I don't know. Hello everyone, and welcome back to Universe Sandbox. And in this video, we are not going to be messing around with the solar system. Instead, we're going to open a brand new system. And in this video, we're going to make an entire solar system of habitable planets, gaseous planets, and who knows what else, around the largest known star, Stephenson 218. This star is almost incomprehensibly large. Its radius, not its diameter, its radius is 10 astronomical units. An astronomical unit is pretty much the distance between Earth and the Sun, depending on where Earth is in its orbit. Hopefully I explained that clearly enough, but to make it more clear what I said, an astronomical unit is the distance between the Sun and the Earth. However, it's only at one specific, or two specific points in the Earth's orbit, I guess, technically. No. One specific point, I think. I don't know. You get the point. But, yeah, so. This star is 10 astronomical units large, but it's not very dense. It's only 40 solar masses. Only 40 solar masses. That's still insane. To put that in perspective, that is around 13 million Earth masses, or that many kilograms. So, and again, this is the behemoth of a star we have to make an entire solar system around. Let's see what the habitable zone looks like. And you know what? I'll explain the rules of this challenge now. I am not allowed to use any of these pre-built planets. That would be cheating for sure. Because the goal is to make a fun system, not copy and paste the solar system. I am allowed to use the random rocky planet, gas giant, or exoplanet, but that doesn't sound super fun now, does it? So yeah, let's get this started. We're gonna have let's say there are 10 planets in this system, and the first closest planet will be 500 astronomical units away. Its current speed, 8 kilometers a second. It takes 1,700 years for this to orbit the star. But frankly, we're going kind of slow right now, so let's speed things up and see what happens. Currently, the temperature reaches around 300 Fahrenheit. Huh. So that back down to around 17 days per second. In the solar system, this would make for a nice middle ground between seeing the planets rotate and it not being too fast. In this, it's almost incomprehensibly slow. Well, not incomprehensible, but yeah. So, to make this more like Mercury, because that's sort of the inspiration here, we're going to drop its mass, drop its radius. We're going to increase its density, though. There. Now its surface gravity is quite weak, because it's 1,000th mass of Earth, but still. So, this planet is now quite small and quite dense. But sadly, it only looks like this because of how boring these basic planets are. So, let's do some terraforming. That's what that does, okay. I'm gonna make a giant basin on this side of the planet. Come up with whatever space theories you want about it. I find that these work better if you just click it so it makes an actual, sort of mountain range. Doesn't look great because I suck at planetscaping, but hey. Let's say that its atmosphere is very thick with hydrogen because, it is close to the star. So yeah, it now has a fairly thin hydrogen atmosphere. So yeah. If you want the semi-scientific explanation, I'm not an expert in planet formation, to be clear, but let's just say some hydrogen that was forming the star was blown away and ended up on this blank planet, which with its temperature actually decreasing, we're gonna add some greenhouse gases to this. Yeah, now that I've added a lot of methane to the atmosphere, pretty much a similar amount to the amount of hydrogen. For some reason this planet's not getting much hotter, even though methane is a pretty strong greenhouse gas last I checked. Also, there's not really anything going on this side of the planet, so we're gonna make a little, we're gonna make, maybe, this side could have, be covered in craters, because it's, this is the area where a lot of meteors hit, I guess, I don't know. Yeah, there's probably a more efficient way to pepper this planet with asteroids. So the method I'm going to use to make this look more realistic is, you guessed it, I'm going to actually pepper the planet with asteroids. Well, now that seems like it could risk destruction. This thing itself is pretty much an asteroid. Seriously, it's like the size of a state. Let's also add some CO2 to the atmosphere. Okay. Oh, this planet's spinning pretty fast, huh? Oh yeah, it rotates like once every hour and 45 minutes, pretty much. Also, its surface gravity is pretty high. I'm gonna quick drop its density a bit. It's still a pretty, dense planet, but this is more reasonable at least. Its surface gravity is now a bit different. I don't know why it sets all the measurements to milligrams just randomly, but whatever. So, this is what it looks like with clouds. So this is what it looks like with, I believe this is atmospheric haze. Without. The clouds of hydrogen look so cool. It's just that you can't really see them because of the atmospheric haze. Alright, what the heck is going on here? Did I add some liquid, like whatever there? And why do the clouds rotate in the opposite direction at the poles? Is this just like something that happens in real life, or? No. So. I'm gonna slight tilt. So, yeah. I think that'll be it for this blank planet, which, due to its honestly not extremely high heat, but it's the closest planet, so it shall be called the hot planet. Now, for the next part, instead of just modifying a blank planet, we're going to summon a random rocky planet. Well, there goes our random rocky planet, I guess. It just got yeeted away. The next planet we're using, is this thing orbiting in the opposite direction? Because if so, that's pretty cool. Nope, never mind. No, I would like to include some sort of planet on the outskirts that orbits in the opposite direction. That would be cool. So, this planet... I can work with this. Alright, so... we have the planet. We just have to make it actually interesting. Wait, this planet's kind of sick, not gonna lie. Like this giant... I believe this would be a basin on this side. Sadly, it's slightly too warm for water to exist, so I can't do anything with that, really. But... be cool. So... I know what to do with this one. Oh, I actually... wait, no, that's the gas, I guess. Some hydrogen, some oxygen froze, I guess. I don't know. Either way, let's just... cool, there's a little polar ice ring now, I guess. That's a lot of hydrogen. That's a lot of oxygen. Like, I'm pretty sure that much oxygen could be dangerous to, you know, inhale. I guess the polar regions are super cold. How quick so this rotates every 4 days? That's neat. It already has quite a bit of obliquity, so... or... obliquity... I don't know. Alright, so... Stevenson 218 now has 2 planets. This system needs to have 10. But now we have the most fun part of this entire thing. The part where we make multiple habitable planets. Well, first I should... as cool as Later always has a name. Or... Lairo? I don't know the proper pronunciation, so honestly, so it does. We need to have custom names at least. This one is the Warm Planet. Until I come up with a better name for it. So, but now we actually need to have a blank planet. Let's see what temperature it gets up to. Average temperature of 60 degrees, okay. I can work with this. It's kind of super Earth, but you know, it's still hospitable in theory. It rotates insanely fast, so that's neat. Seriously, it rotates 8 times faster than the Earth. Good thing it doesn't have an atmosphere yet, because that could have disastrous consequences for the entire ecosystem. I don't really know. I'm about to give it an atmosphere. a bit of oxygen, now a lot of nitrogen, because I guess, that's what the Earth is largely made of for some reason. A bit of CO2. Okay, the planet didn't just expand, I just zoomed in on it. Good, that could have been weird. Because if the planet just randomly expanded because I added CO2, I would be afraid, I'm going to be honest. I'm going to have both of these quantities, because that way the atmosphere isn't as, dense. Now, I was a bit confused on why I didn't have a lifelike good for a second. And I remembered, oh wait, it doesn't have water. Like the most crucial thing for life. But you know what? Water's not really what this planet needs. It needs some cool it needs some cool mountains that cover most of the surface. Say that these mountains are formed by a incredibly, it's due to an intense geological core heat. I don't know, it's causing tectonic plates to, move more. Look. So there's a bunch of mountains that pretty much split up the entire world. This could actually use this as a story for a fantasy game or something, I don't know. So, time to add water. I found that you can honestly just kind of add water everywhere and let the elevation take care of it, but so that's what I'm gonna do. Water everywhere. Give it a good while. Is it all evaporating or something? So there's no water. Why isn't there any water? Why isn't the water staying? I am confused. Why isn't the water? Alright, the average temperature dropped a lot. Huh. Then it's back up to 50 degrees Celsius. Was the water cooling off the planet somehow? Alright, where's the water going? Is it in the atmosphere? Yes. Wait, no, it does have an ocean. It did a lot of water, huh? Is that the issue? I just don't have enough water? I have a giant ocean, but it seems to be shrinking really quickly. Why? What's my planet's... Why is it so high now? Is it the extra stuff in the atmosphere? Alright, I'm gonna cut all of this, because quite frankly, that's a lot of water to have in the atmosphere. And it immediately froze. Wait, what? Alright, I think its atmosphere might be too hot. Wait, no? It's not too big of an atmosphere. Huh? Why is there just like... Huh? So it's definitely the average temperature of the planet being way too high. So... Luckily, there's a way to solve this. This is what the habitable zone for this planet would be. This one is... What should this one be called? Oh, to continue on theme. It has now been 100,000 years since I began working on this system. Also, why are all of the blank planet's attributes just randomly shuffled every time? It's kind of annoying. Like, what do you mean this blank planet would be habitable at 620 light years? It'd be really funny if, due to Stevenson 218's short lifetime as a star, it just blew up randomly in the middle of recording this. Like, the star in game, not the star itself. Although that would also be pretty funny, not gonna lie. Like... You know, I wanted a cold, habitable planet. Starting to think that the trick is just gonna be not putting any, like, greenhouse gases in its atmosphere. Just like oxygen, nitrogen, water. That's it. That's all you're getting. Oxygen, gas. Oh, I ain't adding anything to it, okay. Slow this down and see what the planet looks like. Huh, that's cool. What's its composition look like by layer? Huh. Reasonable enough atmosphere, okay. It does have a small liquid nitrogen ocean, but... Huh. Wow, yeah, it does have a... Maybe that's what all of it is. All the random water or liquid has been on plants. It's just... Wait, shoot, I added water vapor. That's never good. Bam, no more water in the atmosphere. Alright, and yep, it caused apocalyptic climate change. Huh. Wait, did it just go to the other side of its orbit or something? Well, let's speed it up and see how it gets. Alright, throughout the entirety of its orbit, it's still increasing temperature. Oh, great. This blank planet, I have one very simple solution to fix this. Increase distance. And then, paracenter locked, decrease approach center. Approach center locked, increase paracenter. I'm gonna and then I lock paracenter and I decrease approach center. Whoa. I sure do like how it feels to spend half this video manipulating planet orbits until I find whatever works. How fun. Alright, so you know what? Let's make this planet actually kind of a nice place to live. Step 1. Wait, this already has a pretty good life likelihood. Nice. Alright, yeah, that's a good looking magnetos field. I feel like this is instantly gonna increase its life likelihood a bit because now no longer the sun is a deadly laser. Because not anymore. There is a blanket. Didn't actually jump up all that much, whatever. It didn't jump up at all, I guess, but still. So this planet's looking pretty good. I want to add a moon to it. It'll orbit from this far away. Sima is around twice as massive, is 1.5 times as massive as the moon, give or take. Wait, what the heck is happening to the blank planet? Is because of how far away it is making it strongest? Oh, that's bad. That's really bad. Because of how close it is and relative to, I have to get rid of Sigma because sadly it just is so close. It just is pulling around the blank planet. So I have to delete it. Or I could, I guess, decrease its mass a lot. Alright, I've decreased its mass a lot, and it's now a lot smaller. Alright, now Sima, you can't even really see it, but because of how small it is. But hey, it's not bringing the planet closer to its fiery doom anymore, so that's nice. Alright, great. So this planet is a fairly nice place to be, so it shall be called the Nice Planet. And I think that because of how big of a project this is where I'm going to end off the video. I'll see you again soon. Thanks for watching, and bye-bye.